Here's another look at this rule within a rule phenomenon. Again, we have a quotient, because this has a top and a bottom, and within the denominator, we have a product. So we're going to have quotient rule and product rule happening one in combination again. So let's see what we can do with this. df dx equals. So our rule tells us that we have, again, I'll map this out, and I find this helpful, and you may not need to do it forever, but you might find it's good, especially in your first couple days of trying these. We're going to have bottom times derivative of the top minus top and derivative of the bottom. Now, I happen to know from the way this is laid out that derivative of the bottom is going to be the really epic step, so I'm going to give that a little more space. And then all that is to be over the bottom squared. So let's go through and fill this out and see what we can do with it. The bottom is x plus 3 to x minus 7. Unchanged, you just copy it. Derivative of the top, what do we have? 9x squared minus 12. Minus the top, just copy it. Times the derivative of the bottom, and now this is where the second rule kicks in, because when we go to do the derivative of the bottom, we look at the bottom and say, wait, that's a product. I must invoke the product rule now, which says you do first d second. Derivative of the second is simply 2 plus second times derivative of the first, which is just the number 1. And that's all over the bottom squared, which means x plus 3 squared and also 2x minus 7 squared. You could bracket those and put an extra square on the outside, but I'd rather have it like this because it means we need fewer brackets. Okay, so bottom d top minus top d, and then when you get to the bottom, that's where the product rule kicks in within the quotient rule, and you get this, what we call a nested derivative, or a derivative in layers, usually nested. So, can we clean it up? Yeah. Do we want to clean it up? No, but we should, so let's go. Let's see, I will FOIL this first because these are side by side. We get 2x squared minus 7x plus 6x minus 21, and all that will be multiplied by 9x squared minus 12. To save time, actually, no, I'll do that in a minute, sorry. For now, never mind. Minus 3x cubed minus 12x times, and what do we get from this? 2x plus 6. 2x plus 6 plus 2x minus 7. All over nothing happening in the denominator, I'm just copying it. Okay, now to save time, I'm going to collect these two terms into minus 1x. I'm just going to erase what's there and write minus x instead. Minus 1x minus 21. And where else was I going to do that? Over here, we have 2x plus 6 plus 2x minus 7. That adds up to 4x minus 1. I'm going to do that now so I don't have to rewrite the entire expression. 4x minus 1. Okay, good. Now we can distribute some more. This 9x squared minus 12, we have to distribute the trinomial through the binomial, and we get to FOIL over here. So that will give us a small mountain of terms. 2x squared times 9x squared, 18x to the 4th. 2x squared times minus 12, minus 24x squared, Minus 1x times both of those things gives minus 9x cubed plus 12x. Minus 21 times both of those things gives minus 189x squared plus, 210, 252. Minus, big bracket, now we FOIL all this. 12x to the fourth. None of this is really all that hard. It just takes a long time. 48x plus, 48x squared. It's very important to not screw up right after you've said something isn't hard. All over x plus 3l squared, 2x minus 7l squared. Another time-saving thing I'm going to do, because I'm slowly running out of screen here, this negative applies to every single one of these four terms. I'm going to do that now. I'm going to delete these brackets, and then I'm going to go through and flip the signs. So this will become minus 12x to the fourth. There we go. This will become plus 3x cubed. This will become plus 48x squared, and this will become negative 12x. And now that I've done that, I can dump those brackets. And there. Okay, I think that just saved me a line of writing. If we collect terms now, fourth power is my highest. 18x to the fourth minus 12x to the fourth gives 6x to the fourth. For cubes, we have minus 9x cubed. Plus 3 takes us up to minus 6x cubed, and that's where it stops. For squares, we have minus 24x squared. Minus 189 takes us to minus 213x squared. Minus 213 plus 48 is minus 165. All right, that was too much mental math. I'm going to run that through the calculator real fast just to make sure. Minus 24 minus 189 plus 48. Good, minus 165. For x's, we have 12x minus 12x. Those just cancel. And we have plus 252. And all that is over x plus 3 all squared to x minus 7 all squared. I believe that should be it.